Hello there. This time we're going to discuss articles 114 and 115 on page 72 and 73 of our textbook College Geometry. Um, these articles focus on the properties of the bisector segment or the angle bisector segment that corresponds to the two of the angles of the triangle. So, in a triangle, the larger of two angles has the shorter internal angle bisector. What does that mean? T sub C is the bisector of this particular angle. The associated angle segment bisector is this segment EC, while T sub B is the ray that bisects angle B, and segment BD is the associated angle segment bisector. Okay? And you notice in this diagram, angle B is 58 degrees and angle C is 37 degrees. That makes angle B larger than angle C. And I made it in such a way that the values change. But at this point, when this point and that point coincides with the other points, I end up with equal values and I end up with an isosceles triangle. Okay? So I made it in such a way that I have this particular segment here that will coincide with C sub 1, and hence I end up with an isosceles triangle. So that's my guide, and that's the reason why C is only from this point onwards, away, not inwards. Okay? So if that's the case, I will have to close it, and that's it. So anyway, if angle B has larger in value compared to angle C, then the corresponding angle segment bisector, or it's called internal angle bisector, are also unequal, but this time the inequality will change from greater than to smaller. 13.6 is smaller than 17.6, and in this case 12 is smaller than 15. Okay, so that's the value of 15.2, and that is 12.95. But I want to exaggerate it. Let's make it like that one. Okay, so this is an extra added feature of what I wanted to do, because as part of the proof, I have to construct something. Okay, so first I want to construct, this is what I am doing right now. I need to construct DBF. Okay, so that this angle here, DBF, is actually congruent or equal in value to ACE. Keep in mind that since this is larger in value in here, so I can get a smaller portion in here that's equivalent to that. So again, construct DBF so that DBF is actually equal in value to ACE and ECB. These two are equal to each other. So this is equal to this is equal to this. And if that's the case, then we have two similar triangles. And I color them. One is this blue triangle here. Okay, BFD is similar to yellow triangle FGC. Okay, why is that the case? Because angle F is congruent to itself. There are two overlapping triangles. So this is congruent to itself, and this one is constructed to be congruent to this one. And because two pairs of angles are congruent by AA similarity postulate, we have triangle FBD is similar to triangle FCG. Okay? And with two similar triangles, we definitely have proportion. BF is to CF as BD is to CG. Okay, so we have this inequality. However, okay, let us hide first the blue and the yellow, and let's focus on the red triangle BFC. In this particular triangle, angle B, sorry, okay, angle B is larger in value to angle C. Okay, so this, and that's based on the given condition. Okay, so B is larger in value in C, and in that case, still with this triangle BFC, this is also true. But since we know from our elementary geometry that sides opposite the smaller angles in a triangle is also smaller in value, since this C is smaller than this, the segment opposite this is BF, must be smaller than opposite B, which is CF. So we have BF is smaller than CF. Thus, I will put the results together. So since BF is smaller than CF, that's this one. And this proportion is true. So BF is to CF, but this is the smaller and this is the bigger. Then in this equality, this must be the smaller and this must be the bigger. So BD is smaller than CG, or BD is actually smaller than CG. Now I will put the results together. BD, which is actually the angle bisector, is smaller than CG. Where is CG? That's CG. But CG is also smaller than CE because this is where E is and this is where G is. And therefore, we have that result and we just prove the theorem. Now, an immediate consequence is so obvious, and I've been saying this already. Okay, so let me drag this once more, and show the yellow and the blue. I drag C one more time until F. Now we know what F is. Coincides with A and G coincides with E. That will only happen when you have angle bisectors, okay, base angles that are congruent to each other. This is congruent to this one, and no matter what, the two angle bisectors BD and CE or CG will be equal to each other. So, if two internal bisectors of a triangle are equal, then the triangle is an isosceles triangle. And as I have said, if the angle bisectors are congruent, then triangles BFD and FGC. So FBD and FCG are congruent to each other instead of being similar. Okay? And because of that, BD is equal to CG is equal to CE. So BD is equal to CE is equal to CG. Hence, we're done. Thank you very much. See you.